Dear friends, today I am going to discuss a very important chapter of class 11th. This is a part of one important branch of physics called as mathematical physics. So mathematical physics is a important branch of physics. Mathematical physics. So the question is coming to your mind. What is the need of this mathematics and physics? You know, mathematics is the language of physics. If you know mathematics, then we can understand physics. It is a part of physics. It's a language of physics. So first we have to know mathematics, some mathematics, to understand physics. And basically in this branch, we have to read about differentiation, integration, and vector. Also matrices is there. But today I am going to discuss one part of this mathematical branch of physics, that is vector. Let me tell about this chapter. What is this vector actually? What is the importance of this vector in your physics learning process? This is such a chapter which is the basic of all the chapters of physics. This is the fundamental chapter of physics. If you can't able to understand this chapter, then almost all chapters of physics you will understand zero. You can't able to understand anything from other chapters of physics if you have no knowledge about vector. It is such a chapter, without this chapter you cannot proceed in physics. One thing I am telling, suppose you don't know addition and subtraction, you can't able to lead your normal life. You can't go to the grocery shop to buy something. You can't go to the vegetable shop to buy something. You don't know addition and subtraction. The same role this vector chapter has in physics. If you don't know about vector, if you don't know addition of vector, subtraction of vector, multiplication of vector, then you can't proceed to other chapters of physics. So this is a very, very important chapter, the basic of physics. So let us start this chapter. So before this chapter, let's discuss quantity are classified into two types: physical quantity and abstract quantity. What do you mean by physical quantity? The quantity used in physics. No, don't tell the definition like that. The quantity which can be measured is called physical quantity. Which can be measured? Then the question coming to your mind, quantity which can be measured. So let's discuss about some example of that quantity. What are the examples? Retail mass, that is measured. Length, it is measured. Time, always it is measured. So volume, force, momentum, acceleration, velocity, all these quantities are called as physical quantities, and you will get many number of physical quantities in your NCERT book in last page. Many quantities you will get there, many physical quantities. Then the question is coming to your mind, if quantity which can be measured as physical quantities, there must be some other quantity which cannot be measured. Yes, there are some quantities which cannot be measured, and they are called as abstract quantity. They cannot be measured. Quantity which cannot be measured. If I will give you the example, then you can able to understand. Which cannot be measured. So abstract quantity example is love, emotion, anger, affection. So these quantities you can't able to measure. So as you can't able to measure, also you can't able to compare. But these quantities you can able to easily compare by the data, by the values. But these quantities you cannot compare. You don't know that your mother has more affection for you or for your brother or sister. You don't know that. There is also no such device, no such meter, affectionate meter. There is no such like affectionate meter which can measure the affection of your mother. That affection is towards you, it's more, or towards your brother or sister, it's more. You can't able to measure that. Only you can able to feel. Feelings also, that is one abstract quantity. You can't able to measure how much feelings you have for others. So those quantities, they are none of our business. We will not discuss about these virtual quantities. So our business in physics about only the physical quantities which can be measured. These physical quantities are again classified into different types. You may tell fundamental and derived. Fundamental, derived depending upon the dependence. These are the base quantities, these are the dependent quantities. But today I am not going to discuss about this type. This already you have read in unit and dimension chapter. But I am going to divide this physical quantity on different bases. Let's come to the example. After that, I will tell you how these physical quantities are classified. Let's come to an example. So once what happened, you went to the market. Your mother told, go to the market and buy some oil, mustard oil. You went to the market to buy some mustard oil. You then asked to the shopkeeper, to give some mustard oil. Then the shopkeeper asked you how much you need. Then you told 2 liters. You told I need 2 liter mustard oil. Which quantity is involved here? Which quantity? How much mustard oil? You told 2 liter. Which quantity, which physical quantity is involved here? Okay. So you are thinking the quantity is here volume. Quantity involved here volume. Means you asked for 2 liter volume of oil. Then the shopkeeper also understood what you told. Shopkeeper kept the oil and you brought the oil to home. Job is over. You told to the shopkeeper also understood, problem solved. But I am telling you another situation. Another situation I am describing you. Suppose this is your Kalpana square. Kalpana square this is. From Kalpana square one road is there. Okay. So this is, suppose your edge square. This is your edge square. Okay. So from edge square, the different branch roads are there. This is the road directly towards Governor House. One road is here. One road is here towards Unit 6 Hospital, or towards airport, can I write? Towards airport. This road, and one road is here which is going towards Acharya. See, from Kalpana Square, one straight road comes on the overbridge to Edge Square. Then this road divides into 3 parts. So I am telling you once what happened. You and your friend, 2 friends, they travel with very high speed, costly vehicles from this Kalpana Square. They travel at a time, but what happened? One of your friend traveled very fast, and immediately he from Edge Square he went somewhere. But as you travel slowly, as you travel slowly, then when you come to AG square, then you couldn't able to know where the friend went. Then what happened? You asked to the traffic police there that, sir, my friend who come with a high speed vehicle, with a high user vehicle, actually went where? I want to know. I will get my friend where now. When you ask to the traffic police, then traffic police actually noticed that your friend, and he told, you will get your friend 2 kilometers away from this square. 2 kilometers away from AG square. Traffic police told like this. Traffic police told 2 kilometers away from AG square. Now your friend is at 2 kilometers away from AG square. Okay, he crossed this before 3 or 4 minutes. He was with very high speed, and he almost at a distance of 2 kilometers away from AG square. Then you could able to understand, and immediately you start following your friend or not? Not? What happened? Why you immediately couldn't able to start towards your friend? What problem you face there? The problem is traffic police told 2 kilometers from AG square but didn't tell what? Direction. From this square, 3 roads are there. But traffic police didn't tell you the direction. But if the traffic police will not tell the direction, then you can't able to understand. But if traffic police will tell the direction, you see, suppose traffic police will tell 2 kilometers towards airport, then immediately you understood the thing. You see, so this quantity is actually displacement. This physical quantity which is involved here is called as displacement. What I want to tell you, when traffic police told only 2 kilometers, then you can't able to understand. But when traffic police told 2 kilometers towards airport, immediately you turn your vehicle and start forward. You can able to understand. See, you compare these two quantities. Now you compare. What will compare? Comparison here. One quantity, volume, only you tell 2 liter. This is called magnitude. This is called magnitude. When you tell only magnitude, then you could able to understand, or the shopkeeper could able to understand. Anybody can able to understand. You will tell only magnitude 2 liter. Okay, this much. It is sufficient to explain this quantity. But this much is not sufficient to explain this quantity. What is important here? Also, what you have to add? Direction. So, can you now classify the quantities? How they will be classified? So, what is the classification? One quantity which has only magnitude don't need any direction. But one quantity which has both magnitude and direction. Without direction you can't able to understand. It needs both magnitude, direction, but it needs only magnitude. Then the question may come to your mind, sir, knowingly you have left the direction here. Sir, you add the direction, no problem, everything will be also okay. We'll add the direction here. Let's add this direction here. That you ask to the shopkeeper, sir, give me 2 liter of oil towards the airport. 2 liter of oil towards the airport you give me. Then what the shopkeeper will understand? Shopkeeper will tell, this boy is bad. Okay? Because when you add direction here, then you can't able to understand, because it needs only magnitude. And when you remove direction from here, then also you can't able to understand, because it needs direction. One doesn't need direction, one needs direction. So now I think you understood the classification of physical quantities. On this basis, who needs direction, who doesn't need direction, accordingly we will classify the physical quantity now into two types. What is the classification? So the classification is physical quantity, scalar and vector. Scalar and vector. But in some books you will find also another type, that is tensor. Though nothing is written in your book about tensor, but some books are writing, for that I am telling you also this quantity. So what is this scalar? The quantity which has only magnitude. Always try to write simple definition. Don't go to any complicated definition. Simple definition which everybody can understand. The quantity which has, the physical quantity which has only magnitude is called scalar. So such example of such quantity which don't need any direction. So those quantities are mass, volume, density, like this. You can write a set of quantities which don't need any direction, called as scalar. Then come to vector. The quantity which has both magnitude and direction and obey the laws or obey vector algebra, or you can tell obey the laws of a vector addition, or you can tell obey vector algebra. I add something in the definition. Initially I told you the quantity which has magnitude, both magnitude and direction, called as a vector, but I add something there. Also it has to obey vector algebra, means the laws of a vector addition. I'll tell you later in my next video about the vector algebra. There are certain rules, certain laws are there which the vector has to obey. If those laws, the vector, the quantity will not obey those laws, even if it may have magnitude and direction, still it will not be called as a vector. Remember, a quantity to be a vector, it should have magnitude, it should have direction, it has to obey the laws of vector addition or vector algebra. Okay, remember these things. So which quantity like this? Many quantities are there: velocity, acceleration, force. All these quantities, they has magnitude, direction, also obey vector addition laws. But some quantity I am telling you, they have magnitude, they have direction, but they do not obey the laws of vector addition. Those quantities, though they have magnitude, direction, will not lie in this group. Who are those quantities? One quantity is current, one quantity is time. Direction doesn't mean it's always east, west, north, south. Direction can be also up, can be also down, can be left, can be right, can be forward, can be backward. Direction also can be like this. Can be from positive to negative, negative to positive. So this current has direction from positive to negative. Always current flows in a wire of the cell, but it doesn't obey the vector algebra, the laws of vector addition. What are the laws of vector addition? When I will tell you in the next lecture, you can able to understand. So this current is added simply. Simply this current, suppose in one wire current is going 2 ampere, in another wire current is going 3 ampere. If I tell you when both current combine, you add these currents, how much current will pass? 5 ampere. This right? What you are thinking, answer is right. But according to vector laws of addition, the value will not come like this. But in current it is coming because it doesn't obey the laws of vector addition. So current, though it has magnitude and direction, but still it is a scalar quantity because it doesn't obey the laws of vector addition. Time, also it is always proceed in the forward direction, that is its direction. Still it is a scalar quantity. So this is about the scalar and vector examples. If you come to tensor, some books will find what do you mean by tensor. Some books will find the answer. The quantity which has no specific direction is called tensor. But in higher class when you go, you will read actually what is a tensor. It should not be in plus 2 level. Some books should not raise the word tensor, but as the books are raising, for which only I am telling you, actually this is also a tensor, this is also a tensor. Tensor of rank 0 is called scalar. Tensor of rank 1 is called vector. Also tensor exists of rank 2, rank 3 like this. Okay, so but one example of tensor I can tell you, which one you will read after some chapters. Moment of inertia. This is one example of tensor. But you don't know this quantity. This is totally new for you. Okay, so don't think about it more, because this is not none of our business. We will not discuss this tensor quantity. So don't think more about that tensor. Our focus will be on vector, because scalar, it's nothing what you have read in your school level, that was the scalar. So now our focus will be on vector. So let's write a vector. One vector, suppose suppose one vector is 2 kilometer to east. It is a vector quantity because magnitude is there, 2 kilometer, east direction is there, so it's a vector quantity. So here in this quantity, whenever we'll write a vector like this, we'll present it by a symbol. We'll do the symbolic presentation of a vector. How we'll present it by a symbol? It's presented by any English alphabet with an arrowhead above it. Any English alphabet with an arrowhead above it. This is the symbolic presentation of a vector. You can write capital letter, you can also write small letter, no problem. You also can present it by bold letter, doing bold like this. But will you feel comfortable making bold in your copy while writing an exam? No, you will not feel. So it is better to type in computer and it's better to write in copy. I know you will follow this one. English alphabet with an arrowhead above it. This is the symbolic presentation of a vector. Also by bold letter, you forget it. Then how will present its magnitude? Magnitude is presented like this. Symbolic presentation of magnitude. A vector. Magnitude is 2 kilometer. Or you can write 2. Only 2 also. You can tell the magnitude. This is the magnitude of vector. Symbolically you can write it. Also you can write simple A. Magnitude of the vector. What about this part? Direction. How will present its direction? A cap. Or this is also called a hat. This is the symbolic presentation of direction, which is to east. To east. So if I write a vector, this part is a vector mod. This part is a cap. Now you combine both. A vector mod into a cap. This is the first formula of vector. First formula of vector. Very important formula. In all chapters you will use this formula, what I told you. In all chapters vector formulas are required in physics. So this is the first formula of a vector chapter. You now got it. So this is the symbolic presentation of a vector. But how will present a vector geometrically? Let's see. To this one, how I will present it geometrically. Now let's see. Suppose you make it little long, suppose 5 kilometer to east. 5 kilometer to east. So this is the point. From here the vector I will present geometrically. I will draw a line of how much meter long? 5 kilometer, 5 kilometer towards east. This side is east. 5 kilometer to east. I will draw a line. Now my whiteboard is over here. Then I will go away from this. Not possible. How will draw? Then 5 kilometer vector. How will draw this? So we will take scale. 1 kilometer is equal to 1 centimeter. Then 5 kilometer is equal to 5 centimeter, as you have done in your lower classes. So we will take scale. But exactly 5 centimeter is not required in physics. You just guess and draw a line. It's over. But exactly 5 kilometer means in scale 5 centimeter. By using your normal scale, you will draw. Not required in physics. Just draw a line. So this is the vector. 5 kilometer is present. This length present 5 kilometer, and arrowhead present the direction. And you write here a vector. What you understand here? The length of the line. This is important. In geometric presentation, the length of the line presents magnitude. The length of the line presents magnitude, and the arrowhead presents direction of the vector in geometric presentation. And this one, the starting point of the vector is called as tail. This is called as tail, and the arrowhead, the last end of the vector, is called as a head. This is tail, this is head. This is the geometric representation of a vector. So if I tell you to draw, if I give you just a question, we will discuss that one vector is 5 kilometer 30 degree with 30 degree 5 kilometer northeast. Another I am giving 7 kilometer 30 degree north of east. How will you present these vectors geometrically? So these are two vectors. One is A vector. This one is B vector. You can present this vector geometrically by drawing this direction map. This is east. This is west. This is north. This is south. You can present them geometrically. So this is the task for you, homework for you. You can be able to try this question. How to present geometrically two vectors. Then let's come to discuss about what is the angle between two vectors. Suppose two vectors you see. This is one vector. This is one vector. This is A vector. This is B vector. What is the angle between these two vectors? What is the angle? The angle between these two vectors. So this angle, you know, just like your geometry in 10th or 9th class, this is the angle between the two vectors, A vector and B vector. I am giving you another situation. This is A vector and this is B vector. This is A vector and this is B vector. So what is the angle between these two vectors? So this is the angle theta. This is the angle between A vector and B vector. Okay? Not okay. Not okay. That is not the angle between A vector and B vector. Then how will you determine what difference you mark between these two? Well, this is the angle, but this is not the angle. Why? Why it is not the angle? Suppose let's take this one C vector. You will confuse the same B side is taking. Let's take this is C vector, some other vector. Or I am doing this is P vector. This is Q vector. Totally different vectors I am taking. Okay. Why this is the angle between them? Why this is not the angle between them? Can you mark any difference in the two figures? Mental ability question. Can you mark? Here the two vectors are joined tail joining tail. But here you will join this one, no problem. Tail head when join at a point, you can't determine the angle like this. This is not the angle. You can determine, but this is not the angle, remember. To find angle between two vectors, they have to join tail or head. Tail joining tail or head joining head. You have to determine like this. In that case only you can find the angle between two vectors. Direct angle is the angle between two vectors. Here tail they have joined. If here they are joining tail head, this is not the angle, then what is the angle between them? Then you can extend this vector in the forward direction without any change. You see here, the q vector I extend in the forward direction. Though no change in the q vector. How? What was the magnitude? Also I take here that much magnitude. Where the direction is here, also I take that much direction. If magnitude is the same, if direction is the same, why the vector will change? The vector, same vector. If this is q, then this is q. Now you see here p and q. P and this black color q, they are not joined tail. But this p and red color q are joined tail. If they are joined now tail, then we can able to find the angle between them. This one is the angle between them. This one, if this is theta, so angle between them will be 180 minus theta. So if they are not joined tail, then you have to extend one vector, and after that you will find the angle. Now they are joined tail. They can not only q vector, you can extend also p vector. You extend this p vector, not extend, just parallelly sit. This one. This is also p vector. How? Magnitude same, also direction same. If this is p, then this is also p vector. Now you see at this point, p and q are joined tail or not? Tail. If they are joined tail, then that is the angle between p and q. Same angle 180 minus theta. This is also 180 minus theta. Corresponding angle. Both angles are same. Any one you can able to do. So what I told you, to find angle between two vectors, they should be joined. They should be joined tail or head. But while finding angle between these two vectors, we get another knowledge. What knowledge we acquire here? One extra knowledge. What knowledge we acquire here? What extra knowledge? A vector can slide along its direction without any change. Second is, a vector can sit parallelly without any change. Means a vector can slide along its direction, or a vector can sit parallelly without any change. So today I just gave the introduction about the vector in this lecture. Then the next lecture we will discuss about the different types of vector. Thank you.